Hello, everyone. Welcome to this edition of the Nature Happy Hour. I'm your host, Don Kloss, and this evening we have an interesting program for you, and it is on butterflies. And this is not the usual information you get about the life cycles of butterflies and about the lives of caterpillars and so on. A lot of this is information that is probably things you did not know, and also dispelling a couple of myths about caterpillars. So let's get started. Now, here are some facts that are probably pretty unusual about butterflies. First of all, a group of butterflies is called either a kaleidoscope or a flutter. Some people, I think, have heard the term flutter used, but a lot of people have not heard the term kaleidoscope used for a group of butterflies. Now, the second thing, and we'll talk a bit more about this, they have compound eyes like a lot of insects do, but their compound eyes are made up of 12,000 mini eyes. And with that, they can see beyond the ultraviolet spectrum, as we do, which is something I will explain in a bit of detail. They taste and smell through special receptors in their front legs. Talking a bit in detail about that as well. And they are evolved actually from a moth-like ancestor. There are 24,000 species of butterflies around the planet. They live for about 40 days as adults, which is a bit long for a lot of insects. Houseflies and mosquitoes, for example, live for about 20 days roughly. Crane flies live for about 14 days. So in comparison to that, butterflies have a bit of a long life. Here, just briefly, is the anatomy of a butterfly. And now some insects I will point out, like houseflies and wasps, for example, have one pair of wings. Other insects like butterflies, moths, dragonflies, for example, have double wings. And in the case of butterflies and also moths, they have a forewing and a hind wing. Most cases, not all, as we will see, but most cases, they have forward wings and hind wings. Like every other insect, they have a head, a thorax, and an abdomen. They have multiple legs, and in their case, they have 4 long legs and 2 short legs. They have antennae, which are rather long for their body in comparison to other insects. The compound eyes, as we mentioned, and a little confusing, misrepresented perhaps, the proboscis, which is not a nose, as we will see. And usually people relate the word proboscis to nose, but that is not the case here. Now, about those eyes. If you look at these 2 pieces of paper, each one has 500 dots on it. I know because I made them myself. And if you would multiply this by 12, made 12 copies of these pieces of paper, That is how many eyes a butterfly has. So 12 copies of these two pieces of paper, that many dots. That's how many eyes. Pretty incredible, right? And about those eyes and what they are able to see, as mentioned, now here is a chart of the visible light spectrum as it relates to us. As you know, as the arrow shows here, we are able to see purple through red, as illustrated here. And in terms of rays and hertz, that is this little light green band here on the chart. That's what we're able to see. Now, the other rays, which we are not able to see down here on the left, the fastest are the gamma rays out in space, which we are not able to see. X-rays, which we know are used in the medical field, which we also are not able to see those rays. Ultraviolet rays, a little bit slower. Those are rays that we also cannot see, and those are the rays that are responsible for providing us with suntans and sunburns. On the other side, to the right here of our visible light spectrum, we have infrared, which infrared light the military uses for things like their night vision equipment. And some hunters use that as well. And infrared is used in cameras and in some astronomy equipment. And then further to the right, the waves, the Hertz waves, which really have not a whole lot to do with what can or can't be seen. We have radar, which we all know what radar is, and that is used in tracking of objects in the air. And then we have what we can hear, television, which we can hear those rays, and we can also see those through television sets. And then FM radio waves and AM radio waves, the slowest of the waves. And if you look at this red bracket down here, this is actually what butterflies are able to see with their compound eyes. So besides the visible light spectrum that we are able to see, they are also able to see ultraviolet rays, which we are not able to see, and they're able to see a certain amount of the infrared light rays. So they can see through their compound eyes quite a bit more than what we can see in terms of light. Really fascinating. Now, we humans and mammals and a lot of other creatures have lungs and noses, which we know are to facilitate breathing. Well, butterflies don't have lungs or noses. They breathe through tiny holes in the sides of their bodies, which are called spiracles. Spiracles are a tube in the butterfly's body and their sides, and their sides are lined with them. And these tubes are open at the skin level on the butter side. And they are simply a mechanism for gas exchange. As shown on the drawing here, oxygen, which is the blue arrow, enters the spiracle and is absorbed into the butterfly's bloodstream. At the same time, carbon dioxide from used up oxygen, this is their waste product of using oxygen, leaves the body through the open end of the spiracle, as is indicated here by the red dotted arrow. So these two processes are continuously happening at the same time. Oxygen moving in to the bloodstream, carbon dioxide exiting the bloodstream, both things facilitated at the same time through these spiracles. So that is what they have in lieu of breathing through a nose and lungs. And on this next slide, I have indicated with red dots on this butterfly where on the insect's body roughly these spiracles would be. Now, this you'll probably find rather interesting. Some truths about butterfly wings. First of all, their wings are actually clear. The colors and the patterns that we see aren't really there. They are reflections of light against tiny scales that cover the wings. They have scales on their wings very similar to fish scales, but like tiny mirrors, they reflect different shades of light from that visible light spectrum, the spectrum that's visible to us. And that is how we see different light patterns, the different colors, the different patterns on their wings. Their wings are clear. We just happen to see through those reflections on those scales, those colors and patterns based on what those different scales reflect from the visible light spectrum. And this is a really good picture here. You can see the clear, almost crystalline nature of the scales that are showing up here in this photo, and you can see that some of them are in fact reflecting some oranges, some purples, some dark blues. Now, the second thing is their wings, when they are flying, they don't flap like a bird's wings in a straight up and down motion. They move so fast, it's kind of hard to tell. They actually move their wings in a figure 8 movement in flight. And this is evidenced by the fact that they don't just fly straight. You've all witnessed that when they fly. They do this kind of flitting around as they fly. That fluttering that they get the name from in groups. They don't fly in a straight line. They flit and flutter around, and they sometimes hover, but they move in all different directions, kind of erratic flight, and it's because their wings move in this figure 8 pattern and not straight up and down like a bird. Now, to dispel a myth, butterflies cannot fly if their body temperature and the temperature on their wings is under 86 degrees Fahrenheit. And that is why they sun themselves. It's been a popular misconception that they sun themselves to dry their wings, and that is not the case. They do not sun themselves to dry their wings. This is strictly done to get their body temperature up to above 86 degrees, because if it's not, they cannot fly. And if they cannot fly, they are more susceptible to be preyed upon by predators. They cannot get around from plant to plant to feed, flower to flower. So it's very important that they are able to fly. It's crucial to their existence. Now we talk about that ancestor heredity. This photo that you see in the lower right is a photo of a fossil, the Archaeolepis main. And Archaeolepis main is a prehistoric moth creature from the lower Jurassic period, 190 million years ago. And this creature is, in fact, the ancestor of all butterflies and also all moths. It was first discovered in England in fossil form in the early 1930s. Now, genes were taken from some of these fossils by researchers, and they were proven to be a match to genes of those taken from modern moths and butterflies. So this character you see here is, in fact, the great times thousands grandfather or grandmother of all modern day moths and butterflies. And as you can see, it's got head, thorax, abdomen, very similar body shape, and it has the dual wings, the fore and aft, very similar wing shapes, and you can even see some remnants of wing pattern exhibited here. Now, another misconception. Butterflies do not migrate to mate. Butterflies migrate to escape cold weather. Again, not to migrate, as has been the belief by many people. And not all butterfly species migrate. Some simply hibernate, and they can do this in egg form, larvae, caterpillar, or, of course, as we know, chrysalis form. As larvae or caterpillar form, they will hide under tree bark, or they will wrap themselves in leaves. And some don't actually hibernate. They go into what is called diapause. And in diapause, as we have seen in some other programs about some creatures, particularly certain reptiles and amphibians, what they do in diapause is they slow down their metabolism. They greatly slow their breathing and pulse. So they go someplace to hide, like perhaps a hole in the ground or a rocky crevice. And in slowing down their breathing and pulse, they cease the need for that time period to eat, to drink, to go to the bathroom, They don't need to do those things as long as they are in this diapause. So they just simply slow everything down. They don't need to do those things that are necessities of normal life. And they just wait out the cold weather. And when it gets warm again, they speed their metabolism back up to normal and they go about normal life. Now, this is some interesting stuff here. Putting on the old feed bag. Butterflies, as was mentioned in the beginning of the program, don't have taste buds and they don't have um, noses and they don't have normal mouths like a lot of creatures, including us. They have sensors located underneath their feet. And the first thing that caterpillar eats after it hatches from its cocoon usually is the shell of the cocoon itself. And butterflies, adult butterflies, have these long tongues in their proboscis that are shaped like tubes. Um, so they don't sip their food, rather, they soak it up through these tube like tongues. And amazingly, adult butterflies do not excrete waste usually. They typically use everything they eat as energy. They convert it all as energy, so they have no need to excrete waste. Very unusual for any type of creature. And now, I think a lot of people have seen this, if not everyone. Male butterflies engage in what is called puddling, as seen in this photo here on the left. They gather in puddles, and it's only males that do this. Many get nourishment in the form of minerals by drinking the water from mud puddles. They need minerals just like we do, things such as iron and calcium and phosphorus and so on. And that's things that are in the mud, in the silt and so on, in mud puddles. And now a lot of people probably don't know this. A group of male butterflies puddling together is referred to as a puddle club. Interesting, right? Maybe the name of a pop band could be the Puddle Club. That's a good name. And it's unusual, and this is not the case in this country, but there are some species of butterflies that drink the blood coming from the open wounds of other animals, of other creatures. They are not vampires. They don't bite and suck blood, but they will drink the blood coming from other animals' open wounds. So I've found that very interesting, and I'm sure you do as well. And butterflies are what is known as polymorphic, which means that they can blend in with their environment. It's like having camouflage, kind of like chameleons do in certain lizards. This allows them to stay hidden from predators, allows them to blend in with their surroundings. And who are their top predators? In this order, they are snakes, birds, which I think a lot of people know, frogs, lizards, dragonflies. Dragonflies love to go after butterflies. And then wasps, ants, and flies. And now the thing about this is that when it comes to wasps and flies, they don't eat butterflies, but what they do is they lay their eggs on the back of butterflies. And now this is part of life, but it's really kind of disgusting. When the eggs of the wasps or flies hatch, those larvae burrow into the skin of the butterflies and feed on their internal bodies, which they're parasitic at this point, and it eventually kills the butterflies. Just kind of a nasty thing to think about, but that's what occurs. Some other things we'll look at here. The largest species of butterfly is the giant swallowtail, as shown in this photograph here. They have an average wingspan of between 4 to 7 inches, and that's from tip to tip. They're pretty widespread, found from New England down to Colombia and Venezuela, and they are also found in the Caribbean. And their habitats are fields, citrus orchards, and hardwood forests. They particularly like the citrus orchards. They love to feed on the flowers of lemon and orange trees, tangerine trees, and so on. That is apparently their favorite. Now, a speed racer, this butterfly here, which almost looks more like a moth, the giant skipper, is the fastest butterfly. It can reach flight speeds of up to 60 miles per hour. And that is faster than the fastest racehorse. If you think about it, 60 miles per hour in most places is almost highway speed for automobiles, right? A lot of places the speed limit 65 miles per hour on the highways and freeways. So they're almost up to that speed, which is just incredible for such a small insect. Now, just a little bit about the monarchs. We all know that monarchs are well known for their migrations. It travels over 2,500 miles every winter. However, they are not the only long distance migratory butterflies we have. Um, we also have very similar the following species. First, we have the clouded skipper, which looks pretty similar to that other skipper we just looked at, that is the speed demon. One thing that's different about the clouded skipper, though, you'll notice it does not have wings situated to where they have fore wings and aft wings. They have an upper pair and a lower pair, which is very different for most winged insects. And again, looking very much like a moth, other than the fact that they have very long antennae. We also have this beautiful creature, the red admiral. It is also a long distance migratory butterfly. Just a very striking pattern, how the orange almost forms a complete circle there. Then we have the cloudless sulfur. So named because the main color in its wings is almost identical to the color of the mineral sulfur when it is in its pure state. And then finally, of these long distance migratory butterflies, we have this beautiful creature, the American lady. Also, some very striking, what we see as color and patterns to the wings. Now, just a little bit more about the monarch because there's something interesting here. I think most people that know anything about them know, as this map shows, that in the autumn, the monarchs that live in most of the United States, in the east here, east of the Appalachians, in the autumn, they travel down, as is shown here, into Mexico, where they are also joined by the monarchs that live in between the Appalachians and the Rockies. And they travel on down into Central America, and also some of them that come down from east of the Appalachians. They also travel through Florida, down through Cuba, and across into Central America. But what's very interesting is the ones that live west of the Rockies, they don't head that way. They come down from the northwest here, down west of the Cascade Range to the northwest Pacific coast and stay there. And those that live in areas like what we call the Southwest, west of the Rockies, Utah and Nevada, Arizona, New Mexico, Arizona, so on. They cross the Sierra Nevadas and they winter along the Pacific coast, as is shown here. And then in the spring, the reverse happens. They go back the opposite direction and go back to where they were in the summer. And as is indicated here, 90% of overwintering monarchs originate within this summer area that's indicated by this red sort of a box here. They end up in where this white box is from Central America by the spring, and then by the summer they reach the red area, of which we are a part right here. Now, a little bit about entomology. Butterflies are of the insect order Lepidoptera, and you might have heard that term before, Lepidoptera. And Lepidoptera is from the ancient Greek, meaning scaly winged, which relates directly to what I had mentioned about the fact that their wings are actually made up of these colorless scales. So in the ancient Greek, scaly winged, which related directly back to the New Latin word lepidopteran, the same word with an N at the end, which means the same thing. And Yes, absolutely. Believe it or not, there is such a thing as lepidopterophobia. It is an actual clinically recognized phobia, and it is people that have, believe it or not, an excessive fear of butterflies and moths. Um, it's hard for me to imagine, but then again, there are people that are afraid of spiders, which I happen to not be. There are people that have a fear of snakes, which I happen to love snakes, and everybody has their fears, and so there are people that have a fear of butterflies and moths, and that is lepidopterophobia. Now, if you have any questions, since this is recorded, you can leave them in the comments section of this Facebook channel, or you can leave them on our Facebook page, Central Ohio Nature. That's it for this program. Again, I'm your host, Don Kloss. Please check out our Facebook page, Central Ohio Nature, or you can also look us up on our website, centralohionature.org. Thank you for watching.